In this lesson, we are going over relative extreme values. So basically, relative extreme values are, so looking at this graph here, this is our relative maximum. So again, we're focusing still on our negative infinity to positive infinity when we're testing for our intervals. So like here, notice again, we're increasing, we're decreasing. Here's our relative minimum point here, right? So our minimum, our relative maximum, because the graph is still going down into negative infinity and continuing up into positive. So that's why this is a relative minimum and maximum value. So if you notice, these are also, if I were to create, right, our slope of our tangent line. So going through this point, notice how the slope is 0. So this is also our critical point. So again, they are, these minimum maximum values are occurring where we have a critical number. So again, where the derivative does not exist, or the derivative in this case is equal to 0. So we are going to use what is called the first derivative test. Now, notice to identify our relative maximum or minimum, we have the same steps that we did in a previous lesson on identifying the increase and decrease intervals, because you have to find the derivative, right, to find the critical numbers by setting our derivative equal to 0. We determined the sign, right, to test each interval, whether it was increasing or decreasing. That is how we're able to identify if we have a maximum, minimum, or neither. So looking here at our, at this visual here to show you. So like, for example, if we are decreasing, giving a value that's negative, and then increasing, giving you a value that's positive, we have a minimum. So same thing here. If we had a positive value because we were increasing, and then a negative value because we were decreasing, and again, that shows a maximum value in this case because we're having to increase, then decrease. So the minimum would be decrease, then increase. Now, if it was neither, so we talked about a couple of these examples, right? It could be neither if when we tested our intervals, for example, and they had both a positive value when testing the intervals, or they were both a negative value. So again, that's when it's neither. So that is our first derivative test. So again, here we go. We are going to first, same steps, right? We've got to set up what are the critical numbers. Here in this case, we're going to set it equal to 0 to find our intervals to test in this case. So first, the derivative. So again, here the derivative is 6x minus 12, right? Because plus 5 goes away to 0. So again, we are looking for where our derivative is equal to 0, the slope. Now we're just solving a two-step, right? Add 12 to both sides. 6x is equal to 12, so x is equal to 2. That is our critical value. So again, right, remember our graph is going from negative infinity to infinity. So we have two intervals that we are going to test. We're going to test negative infinity to 2 and 2 to infinity. And just like in our previous, to test it, we'll choose a value that's in this interval. So we could choose 0 in this case and 3 in this case. Remember, right, no matter what value we choose on the interval, we should still get the same value. So like here, when you plug in 0, you should get a positive value, right? You get positive 5. So here we get 5. Now go ahead, pause the video if you need to. Go ahead and plug in 3 in for, I'm sorry. Oh, I apologize. Let me go back. I accidentally, we are again still focusing on the derivative. Sorry, that's on me. So here we're going to focus on the derivative. We're going to actually use the f of x though today in this lesson. So when you plug in 0 for x, there you go, you end up with negative 12, which gives you a negative value. So now when you plug in 3, you get 6, which is a positive value. So now from the signs, we're able to identify if this is a minimum or maximum, right? So if we're decreasing then increasing, we have a relative minimum at the x value of 2, the critical number. So what we're going to do is now we're going to take our x value of 2 because we need to identify where is this relative minimum, which means now we do need to go back to our original function because this is the graph we're looking at. Where is the minimum value of this graph here? So now we're going to plug in 2 into the f of x function. So we're going to find f of 2. 3 times 2 squared minus 12 times 2 plus 5. So here, right, you get 12 minus 24 plus 5, which is negative 7. So we have a relative minimum value at 2, negative 7. So notice the first steps are all the same. We're just now taking it a step further and identifying what type of value we have here and then using that function to plug in. So here, we'll do another one. But go ahead, pause the video, and get the critical numbers on your own. Here we go. So the derivative here, you should have gotten 6x squared minus 6x minus 36. Now again, remember here we're looking for where the derivative is does not exist, right, or equal to 0. So here we're looking for where it's equal to 0. Now notice you have a trinomial, right? So we do have to factor with our 3 terms. But here you could divide and factor out a GCF of 6. So this is 6 times x squared minus, so that's just 1x or minus x minus 6. So now here, when you factor, what two numbers multiply to get negative 6 and add to get negative 1? Negative 3 and positive 2. So that means we have our two critical values, right? Because 6 is just by itself. It's not 6x. Is 6 equal to 0? No. So that's why this cancels out. And the only critical values we have are 3 and negative 2. So now we set up our intervals. So here we're at negative infinity to negative 2, right? Increasing. Then negative 2 to 3, then 3 to infinity. So again, increasing values, right? Like you always read a graph left to right. So now we can choose what values we want to use to plug into x, right? To test our derivatives sign here. So we're testing the sign of the derivative. So we can choose negative 3 here, 0 here, and 4 here. Now, let's say you chose other values already and you already tested. No matter what, here you should get a positive value. Here you should get a negative value. And here you should get a positive value. So here's what this means. This means now notice we're going positive, we're increasing, then decreasing. So now we have a max here, right, at negative 2. Then we're decreasing, then increasing. So notice here we would have a minimum value now at 3. So we have 2. We have a relative maximum, right, at an x value of negative 2. And we have a relative minimum value at an x value of 3. So now to find what the point is, we now go back to the original function and substitute, plug in x with negative 2 and 3 to get your y value. So practice, pause the video, try this part on your own. When you substitute negative 2 in for x, right? So again, this is 2 times negative 2 to the third minus 3 times negative 2 squared minus 36 times negative 2 plus 14. You should get a value of 58. So that is where the relative maximum value is. So then same thing here, when you plug in x in your value of 3, you should get negative 67. That is the location of the relative minimum. So go ahead and pause the video now and try this one on your own. And here we go. So again, start with the derivative, which is 6x squared minus 6, right? We're looking to see, because this is continuous, so not where it doesn't exist, but where the derivative is equal to 0. So I'll just go ahead, you could solve this different ways. I'll just use square root method, where you could add 6 to both sides. 6x squared is equal to 6, divide here, x squared is equal to 1, and now take the square root. So you get both positive and negative 1. That is your two critical values. So here that means you have negative infinity to negative 1, negative 1 to 1, and 1 to infinity. That is our intervals. So then here, remember, right? You plug in, so like I'll say you could plug in, negative 2 here, or 0 here, or 2 here as well. Make sure that you have plugged into the derivative. You're testing the sign of the derivative for the increase, decrease. So when you substituted any value here for the first interval, you should have gotten a positive value. Here, a negative value, and here a positive value, which means here you have a relative maximum because your increase then decrease at negative 1, that's your x here, and then a relative minimum because your decrease then increase here at the critical x value of 1. So again, here we've got our relative maximum at negative 1, that's our point, and the relative minimum at 1. And then now remember, you needed to take these x values to get the y value and plug into the original function, because that is the graph that we're looking at. We want to know, right, where's the relative minimum and maximum point here. So when you plugged in negative 1, let's see, so you have 2 times negative 1 cubed minus 6 times negative 1 plus 1. So notice here you should get 5. That is the relative maximum point. So then here, when you plugged in 2 times 1 cubed minus 6 times 1 plus 1, you end up with negative 3. That is the relative minimum.